What's going on, everyone? My name is Kodomore and welcome back to the New Beginner Java Game Programming Tutorial Series, episode 27. In today's tutorial, we are going to work on entity collisions, because right now, our player can just walk right over all these entities, all these trees right here, and we obviously want to add collision detection to those entities. So I'd like to point out first that in my tree class, I just quickly set up the bounding box of the tree. That way the bounding box isn't the whole entire sprite, but instead more like the bottom area of the tree. Again, that's just experimenting with values that you know, just like we did with the player's collision detection box. So I just wanted to point that out for you guys. Alright, let's get to collision detection. First things first, we are going to need access to the entity manager. So inside of your world class here, we're just going to go up to source, generate getters and setters, and we are going to generate a getter for the entity manager. That way we can access that in other classes. So I'm going to create get entity manager. And that's it for the world class. Now in our entity manager class, I made a tiny little mistake in the last video. I said in the last video that we should tick and render our players separately from all the other entities. We actually don't want to do that. We still want to keep a separate player instance in our entity manager so that we can easily access it, but the player should still be a part of this entities array right here. So in our constructor here, after we create the entities array, we are just going to add an entity and we're just going to add our player to that array, like so, and then we can remove player.tick and player.render from the tick and render methods, and the player will just tick and render along with every other entity in the game. But we still have an instance or access to it right up there, so if we run our game, you can see it works the exact same. We didn't change anything just yet. Alright, now there are many ways to implement collision detection with entities. Today we are going to do one of the most simplest forms of entity collision detection. It is not going to be efficient at all. The point of this method is just to hopefully get an easy understanding of entity collision detection. This is by no means the best method of doing this, but it's going to work for our purposes. If you are making a gigantic game and you need really efficient entity collision detection, you can look up quad trees and implement a different system. Alright, enough of me talking, let's get to collision detection. Inside of our entity class here, we are going to create a few helper methods. The first helper method we are going to do is going to be a public rectangle. It's going to return a rectangle called getCollisionBounds. Like so, and this method is going to take in a float x offset and a float y offset, and I'll tell you what all this means in a little bit. And all we're going to do is we are going to return a new rectangle object, and of course we have to cast the first parameter into an integer, like so, and the first parameter is going to be x plus bounds.x plus x offset, like so, and we're going to do the same thing for the y parameter, cast it to an integer, y plus bounds.y plus y offset, and the width and height are going to be bounds.width and bounds.height. And that is it for this method. Now what exactly is this method going to do? Well, getCollisionBounds is going to return the bounding rectangle, or essentially the area around this entity, and that makes sense because we are just returning a new rectangle with our x position of the entity plus the offset of the bounding box of our entity. And we're doing that for y, and then we're just returning the bounding box width and height, but we're adding an x offset and a y offset in here that we get from parameters. Now this is going to be kind of hard for me to explain, so don't worry about these parameters just yet. Just know that this getCollisionBounds method returns a new rectangle, and this rectangle covers the area of the entity that's solid, the collision box of the entity. Alright, let's move on to one more method in the entity class, and that is going to be public boolean check entity collisions, and we are also going to take in a float x offset and a float y offset in this method as well. This is the method that's actually going to test every entity in our game and see if it collides with this entity right here. And we can do that by a fairly simple loop. So what we're going to do is we're going to do for entity e in our handler.getWorld.getEntityManager .get entities, so we're getting the list of entities and we're looping through every single entity for collisions between this entity and the entity that we are getting from the loop. So we can do if e.getCollisionBounds, and we're going to put 0 in for both offsets. Again, I'll explain that in a little bit. .intersects, so if the entity that we are looping through intersects our collision bounds, so get collision bounds, like so. And for this one, we are just going to pass in the x offset and y offset parameters that we've gotten through this method. So if this is true, if the two rectangles are overlapping and there is a collision between these two entities, we're just going to return true. There was a collision. And we're going to loop through every entity and do that. If this loop exits, that means there was no collision, and we can just return false. Now there is one slight problem. Whatever entity is calling this check entity collisions method is looping through every single entity in the game, including itself, and we don't want to check collisions with itself. So we have to check, at the beginning of the for loop here, if our entity dot equals this. So if the entity that we are looping through is this entity right here, we are just going to continue, and what that does is it skips all this code and just goes to the next entity in the loop. That way we don't check for collisions against itself. So what exactly is the deal with these x and y offsets here? For instance, in the for loop, we check every entity dot get collision bounds and we pass in 0 for both the x and y offset. Well, if we call get collision bounds with both 0 for the x and y offset, then that's pretty much like the plus x offset and plus y offset not even being there, because anything plus 0 is itself. So it's basically just the x position of the entity plus the bounding box x offset of the entity, and the same for y, and then the width of the bounding box and the height of the bounding box for the entity. So it's just returning a rectangle, the proper size that fits right over the entity for collisions when you pass in 0. But if we were to pass in a number, it would modify these values just a little bit to make it look like the bounding box is at a different position than the entity really is. Let me show you what I mean. Head on into your creature class, and in the move method here is where we are actually going to call these methods and check for collisions. We're going to do if not check entity collisions, and we are going to pass an x move as the first parameter and 0 as the second parameter. Then we want to move x. And we are going to do the same thing for move y. Right above it, we are going to put the if statement here. And of course, remember to replace this with 0 for the first parameter and y move for the second parameter. Now we are actually using those x and y offsets. For the same exact reasons why we call move x and move y separately. What we're doing here is whenever, say, our player moves, it's going to call this move method right here. So if we're going to move left and right, or on the x-axis first, we are going to check with entity collisions where we are going to be moving. So the current x position plus the offset of the bounding box plus this x move offset where we are moving to. And it'll place the bounding box there. That will allow us to properly check for x collisions. That way we're still able to slide up and down. And then we do the same thing for y. We pass in 0 for x move, because we've already checked for that. And then we pass in y move, where we are moving to. That way we can properly check for that, and we're still able to move left and right freely. I hope that's understandable. That felt like I didn't explain it too well, but I can't really put it in many other words. So if you need an extra explanation, leave a comment down below. Anyways, let's go ahead and run our game, and notice how we have perfect collision detection with the tree here. Notice how the collision boxes with the tree and player are working because I set them to be different sizes so our player can walk a little bit up to the tree. Except this obviously doesn't look too good. I mean, this looks perfect. Oh yeah, our player is right behind the tree. He's on the side of the tree. Oh, that looks amazing. Until we get to the front of the tree where the player's head is completely behind the trunk. And that's what we're going to fix in the next tutorial. We are going to learn how to order sprites for rendering. That way it doesn't look like this and it looks more realistic. But congratulations, we finally have collision detection with every entity in our game. Now you might be wondering why we only implemented the check entity collisions inside the move method of the creature. For instance, our static entity, like the tree here, we don't call that method at all whatsoever. And that's because a tree doesn't move. And since a tree doesn't move, we don't need to check it against every single entity for collision detection. That would just be a waste of resources and it would slow down our game. So we only want to call check entity collisions with anything that will be moving in our game, like a creature that has a move method. I hope that all made sense to you guys. We finally have collision detection with entities, and I'll see you guys in the next tutorial where we're going to make our game look a little better and properly render our entities to the screen. Thanks for watching everyone, and I'll see you in the next video.